The Komodo Dragon. You already know this one as the giant lizard that can take down a water buffalo, and the picture in your head is probably the bite doing the work. The bite barely matters. Here's the thing about saliva. Its entire job, in your mouth and mine, is to start breaking down food. And this animal kept the breaking down part and aimed it at everything else. A Komodo dragon grows up to 10 feet long and over 300 pounds, and tucked into its lower jaw are real venom glands that seep toxin into the saliva, flooding every bite. Those toxins drop blood pressure and stop the blood from clotting. So watch what happens. It bites a buffalo once, and the buffalo survives the day, wanders off, looks completely fine. Then the wound won't close, the pressure won't hold, and it's down in a field a mile away. The dragon just follows the smell and essentially makes itself a sandwich and waits. For years, the story was that the kill came from filthy, bacteria-loaded drool. Turns out that whole idea collapsed in 2009 when an MRI study found the actual venom glands. It's not germs, it's chemistry, which makes the Komodo the only predator that wins a fight by losing it slowly. The slow loris. This thing has the face of a stuffed animal sold at an airport gift shop, and it's also the only primate on Earth that can poison you. Watch one when it feels threatened, and it raises both arms straight over its head, like it's surrendering. It's doing the exact opposite. On the inside of its elbow, it has a gland called the brachial gland that leaks a pungent oil, and when it licks that gland, the oil mixes with its saliva and coats a row of needle-like lower teeth. The venom that results is chemically close to the protein in cat dander, the stuff that makes allergic people sneeze, except concentrated into a bite that can throw a human into full anaphylactic shock. Think about the scale of that. You've got a creature small enough to sit cupped in your two hands, defending itself against animals many times its size, and the mechanism is your own immune system turning against you hard enough to kill. The common version of this animal is harmless, adorable, makes a great pet. It's neither. That cute arms-up pose people film and coo over is the loris loading a two-part venom, mouth to elbow, before it bites. The cutest thing in the forest keeps its venom in its armpit. The vampire bat. Picture a sleeping cow out in a field that has no idea it's being fed on. No pain, no struggle, just a slow, steady leak it never wakes up for. That's the saliva doing its quiet work. And the danger here isn't really the bite at all. It's what the spit leaves behind. A vampire bat shaves a tiny, painless nick with razor incisors, and its saliva carries a protein researchers nicknamed Draculin that blocks the blood from clotting. Other compounds widen the blood vessels and dissolve any clots that try to form, so the wound keeps weeping long after the bat flies off. That nick is smaller than your fingernail, but it can keep bleeding for hours, draining far more than the bat ever actually drank. The reason this works is a hard engineering problem. Blood clots fast, on purpose, and the bat solved it by drooling a cocktail that holds the tap open. And Draculin is such a clean anticoagulant that scientists have studied it for human stroke medicine, a clot-dissolving drug reverse-engineered from a bat's spit. It's a flying syringe with a great bedside manner. If you're enjoying creatures like this, I post new animal deep dives like this regularly, and subscribing really helps. Thanks. The Spitting Cobra. Every other animal on this list has to get its mouth on you to do anything. This one doesn't. It can hit your face from clear across a room, and it isn't aiming at your skin or your chest. It's aiming at one specific target, and it almost never misses. A spitting cobra has fangs with small, forward-facing holes, and by squeezing the muscles around its venom glands, it fires a jet of venom up to about 10 feet, consciously aimed at the eyes with an accuracy around 90%, on a moving target. And here's the part that breaks your brain a little. The whole spray is released in roughly 50 milliseconds, faster than you can blink, and the snake isn't aiming at where your eyes are. It's aiming at where your eyes are about to be, leading you like a quarterback throwing to a receiver. Despite the name, it isn't really spitting in the drooly sense. It's a pressurized jet, more fire hose than loogie. Evolution looked at a perfectly good venomous bite and decided it needed a ranged option too. That same fluid that's supposed to help you swallow a sandwich fired across a room and into your eyes on purpose. It's the only animal that can blind you without ever touching you. The Gila Monster. It's a slow, beaded desert lizard you could outrun at a casual walk. And it's also one of only a small handful of venomous lizards on the entire planet. Here's the puzzle though. It has no fangs to inject anything with. So how does the venom actually get in? The answer is slower and nastier. The venom glands sit in its lower jaw, and its teeth are grooved, so the venom wicks up those grooves by capillary action while the lizard bites down and chews, driving the toxin deeper with every clamp of its jaw. Its hunting strategy is, essentially, refusing to let go and waiting you out. There's no quick strike, no clean injection, just a grip that won't open and a chew that works the venom in bite after bite after bite. Most people assume this thing is a frequent killer of people. It's reluctant, slow, and rarely fatal to humans. Its real legacy isn't the morgue, it's the pharmacy, because a compound in that venom became the basis for a major diabetes medication, the same drug family now famous for weight loss. A lizard's drool ended up in millions of medicine cabinets. Evolution kept the boring delivery system and just made the payload worse. The northern short-tailed shrew. This thing is smaller than your thumb. It lives in your backyard, and it runs a private dungeon stocked with living prisoners. It catches more food than it can possibly eat in one sitting, and instead of letting the leftovers escape or rot, it does something unsettling. Its venom comes from glands in the lower jaw, and it contains a paralytic peptide called sorocidin. The shrew bites its prey, paralyzes it, and stores it alive, immobile but still breathing. It runs a tiny pantry full of conscious snacks. A single dose can keep a paralyzed mealworm fresh for around 15 days, a living refrigerator that never spoils because nothing in it has technically died yet. So follow the math. It catches more than it can eat, it paralyzes instead of killing, and that buys it roughly 2 weeks of fresh, motionless food stacked in an underground larder. The reason it bothers is metabolism. A shrew burns energy so fast it has to eat around the clock, and it can't afford for its surplus to spoil, so its spit became a preservative. Its leftovers are still alive when it comes back for seconds. The European mole. Under a perfectly normal-looking lawn, a mole might be sitting on a horde of hundreds of earthworms that are alive, aware, and unable to move. They aren't dead and they aren't decomposing. They're being kept, and the mole's spit is the only thing holding them there. Its saliva contains a toxin that paralyzes earthworms, delivered with a precise bite to the worm's head that shuts down all movement without killing it, and then it hauls the victim off to a dedicated storage chamber. It's meal prepping, except every meal is still breathing. These caches start with a few dozen worms, build into the hundreds, and excavated mole larders have been found packed with more than 1,000 living, paralyzed earthworms, all beneath a patch of ground you'd mow in an afternoon. The logic is simple and grim. A worm is only a renewable food source if it can't crawl away, so the saliva switches off the escape without switching off the worm. The common version of the mole is a clumsy, half-blind garden pest, bumbling around wrecking your grass. What it's actually running is an organized, paralytic supply chain. Somewhere under a tidy lawn is a vault full of worms that can't even scream. The spitting spider. Most spiders chase, or pounce, or build a web and wait around. This one stands dead still, takes aim, and fires. It doesn't bite to start the fight. It spits first, and the prey is pinned to the floor before it understands what just happened. This spider's venom glands produce two things at once, venom and liquid silk, fired in a fast zigzag of sticky, toxic strands across its target. The glue shrinks and tightens the instant it lands, harpooning the prey down to the surface, and only then does the spider stroll over and bite. The spray leaves at nearly 29 meters per second, lashing the victim flat in a fraction of a second. So by now you've watched spit work as a poison and as a long-range weapon. Here, it's a building material, fired and set before the prey can take a single step. The trick is that one gland pulls double duty, the front making the glue silk and the back making the venom, so the restraint and the poison arrive in the same shot. Why pick between a net and a weapon when your mouth can launch both at the same time? It catches dinner by spitting a loaded net, and then casually walking over to collect it. The Mexican beaded lizard. If the Gila monster is the famous venomous lizard, this is the one most people have never even heard of, and it's larger, darker, and saddled with a noticeably worse temper. It shares the exact same rare, chew-it-in venom system, and what really sets it apart is how willing it is to use it. It's one of the very few truly venomous lizards on Earth, with the same venom glands, grooved teeth, and slow capillary delivery, except wrapped in a bigger, longer body that's documented to deliver serious bites to humans. It's the Gila monster's bigger cousin, who never learned how to mellow out. These two lizards belong to a club of basically two. Alongside the Gila monster, they're the only lizards that ever grew a real venom delivery system at all, a design otherwise reserved almost entirely for snakes. Turns out the Gila monster gets all the fame, while its larger relative quietly carries the identical toolkit and reaches for it more readily. There are only a couple of venomous lizards on the whole planet, and this is the one that means it. Turns out the mouth is a surprisingly popular place to keep a chemistry set. The Caecilian. This thing looks like a fat earthworm and lives buried in tropical soil, which is exactly why, for about 200 years, nobody thought to check its mouth for venom. Then in 2020, researchers finally looked closely at those tiny teeth and found something only ever described in snakes before. A Caecilian is a legless, burrowing amphibian, and tucked at the base of its teeth are tiny fluid-filled glands, with ducts that open right where the teeth meet prey. The fluid is loaded with the same enzymes you find in true venoms, and the glands grow from the exact same source as a snake's. If it's confirmed as fully functional venom, this would make Caecilians the first amphibians ever known to bite venomously. Sit with the timeline. This animal had been studied and cataloged for roughly 2 centuries, snake-grade hardware sitting in its jaw the entire time, and the glands got missed until 2020. It spent 200 years filed under weird worm thing, venom and all. The common version was that no amphibian bites with venom, period, and that assumption quietly broke a few years ago. It had snake-grade gear in its mouth the whole time, and it just looked too boring for anyone to bother checking. The African Crested Rat. Every single animal so far brewed its own weapon from scratch. This one decided that wasn't worth the trouble and outsourced its poison to a tree, doing something no other mammal on Earth is known to do. It gnaws the bark of the poison arrow tree, the same bark local hunters use to tip arrows strong enough to drop an elephant, which is packed with a heart toxin called wabane. Mixes that toxin with its own saliva, and slathers the resulting paste onto a strip of specialized hairs running along each flank. Those hairs are built like wicks, perforated to drink the poison straight up. So a predator that bites this fuzzy, unbothered rodent gets a mouthful of one of the most potent heart poisons known to science, and a single bite can kill the animal that tried it. Why evolve your own venom when there's a perfectly good poisonous tree right over there? The common assumption is that venomous animals all manufacture their own toxins. This one manufactures nothing. It's the only mammal we know of that lifts its poison straight off a plant and wears it. The one animal here that couldn't even be bothered to make its own. Saliva started this whole list softening sandwiches. It ends it as the brush a rat uses to paint borrowed poison into its own fur. If you made it all the way here, you clearly like this stuff as much as I do. So subscribe and I'll see you in the next one. Thanks for watching.